In this lesson, we're going to find the area of rectangle MNPQ using a very useful property of similar triangles. So let's work through it carefully, step by step. A diagonal is drawn from point Q to point N, and it intersects the horizontal segment RS at point T. We are given that the area of triangle QRT is 3 square units, and the area of triangle NTS is 12 square units. Our goal is to find the area of the entire rectangle. Let's begin by comparing triangle QRT and triangle NTS. Notice that angle QRT is 90 degrees because the segment RS is perpendicular to the left side of the rectangle. In the same way, angle NST is also 90 degrees, because the segment RS is perpendicular to the right side of the rectangle. Now, pay attention to point T. The diagonal and the horizontal segment intersect there, creating a pair of vertically opposite angles, and vertically opposite angles are always equal. Since we have one pair of right angles and another pair of equal angles, the two triangles are similar by the angle-angle similarity theorem. This is the most important observation in the entire problem, so make sure you understand why these triangles are similar. If you're finding this explanation helpful so far, don't forget to like the video, subscribe to the channel, and let me know your answer in the comments before we reach the final result. Now, one important property of similar triangles is that the ratio of their areas is equal to the square of the ratio of any pair of corresponding sides. So we can write the area of triangle QRT divided by the area of triangle NTS equals RT divided by TS, all squared. And this is also equal to QR divided by SN, all squared. Next, let's substitute the given areas. We have 3 divided by 12 equals the quantity RT divided by TS, all squared. And it also equals the quantity QR divided by S, all squared. Now, simplify the fraction 3 divided by 12. Both the numerator and denominator are divisible by 3, so this becomes 1 divided by 4. Therefore, 1 divided by 4 equals the quantity RT divided by TS, all squared, and it also equals the quantity QR divided by SN, all squared. To remove the square, we simply take the square root of both sides. The square root of 1 divided by 4 is 1 divided by 2. So we now have RT divided by TS equals 1 divided by 2, and QR divided by SN also equals 1 divided by 2. Let's introduce some variables to make the remaining calculations easier. Let RT be equal to A. Since the ratio is 1 to 2, TS must be equal to 2A. Similarly, let QR be equal to B. Then SN must be equal to 2B. Now let's use the formula for the area of a triangle. Remember that the area of a triangle equals 1 divided by 2 multiplied by the base multiplied by the height. For triangle QRT, the base is B and the height is A. Since its area is 3 square units, we can write 3 equals 1 divided by 2, multiplied by B multiplied by A. Now, multiply both sides by 2 to remove the fraction. This gives us A multiplied by B equals 6. Keep this result because we'll use it in the final step. Now let's determine the dimensions of the rectangle. The total horizontal length RS equals RT plus TS, which is A plus 2A, giving us 3A. Since RS is equal in length to the top side MN of the rectangle, we have MN equals 3A. Similarly, the total vertical length MP equals QR plus SN, which is B plus 2B, giving us 3B. Now we're ready to calculate the area of the rectangle. The area of rectangle MNPQ equals its length multiplied by its width. So we have 3a multiplied by 3b, which equals 9ab. From our earlier calculation, we already know that a multiplied by b equals 6. Substituting that value gives us the area equals 9 multiplied by 6, which is 54 square units. Therefore, the area of rectangle MNPQ is 54 square units.